Hello and good morning. Not that I know if anyone's here or not, but hey, I'm here and that's all that matters. At least for a moment. In a moment, I have to go get some tea. But said I was going to be on here, so I am on here. So what was I going to do today? I was going to talk about staying on track while you're trying to do things at home, which, believe me, is something that I am working on as well as you all. All right, my hot water's beeped. I'll be right back. Yeah, I know. Rule one: don't leave dead air and stuff like that. But I'm bad at this, so I'm learning. You're learning. We're all learning. That's the way this goes. Speaking of learning, it's what we're supposed to be doing online now. So, what are some of the problems with learning online? Really, I see essentially a few major things that I think people don't always think about or could stand to be better at. So, when I'm talking about self-directed stuff, you have to do a couple things. First of all, you have to know what you are supposed to be doing. That's really an important concept, to have an idea of what the actual things are that you're supposed to do. And they can't be vague. You have to have what I like to call an action list, which is very different than a task list or a to-do list. So the real keys to actions is that it's something that's immediate and that you can accomplish. So when I'm creating an action list, I want to make sure that the things on it are clear, obvious, and I don't have to think about them. That's really the most important part, is clear, obvious, and not having to think about it. So on my end, some of the things that I'm doing, for instance, involve creating and putting up coursework. So an action item for me might be grade everything in a Blackboard site. I just go right to that site and I click through it and I grade those things. That's pretty easy. Another action item for me might be create an assessment. As long as I know what it's on and what the topic's supposed to be, I can do that. So for students, though, the action items are going to look a little bit different, and you have to be careful about how you do them because different classes might provide them differently. Now, I provide my information as action items. If you're in one of my classes, you pretty much see things as an action. So, for example, define these words. It's a pretty clear action. I try to make it as obvious as possible. But if the information you've been given is not define these words, but read this material, that can be a little bit more difficult because reading, although it's an action, isn't a good learning tool. So then you need to give yourself something else. The other problem that you might have is you have to have action items that are fit into a easy to accomplish time frame in some manner. And so what I'm especially a fan of is using what I would call quantity over quality. So quantity over quality is real important because what it does is it says, well, I'm going to do an amount of and not worry about like a completion. So I give my students a lot of words to define. They could decide they're going to sit down until they define all of those words. But honestly, it would probably take a long time. And you might get bored doing it. You might not. You might really like defining words. I don't know. But you might get bored. But what I would tell you to do then is not worry about defining all the words or even defining a certain number of words. I'd say set a timer for 25 minutes and define as many words as you can in 25 minutes. If at 25 minutes you're like, this is great, let's go, reset the timer for another 15 or 20 and keep moving. Although at that point, take a break because you don't want to go for too long. Same thing with reading. You don't want to read a chapter. You don't know how long a chapter is going to take, but you can read for 20 minutes, and that's a good way to do it. The other key with reading, again, is that part of the problem is that reading is an ineffective learning style. Now, to be clear, listening is also an ineffective learning style. Neither one of them works really well on their own, which is the key to how college usually works, is you get a little bit of both and a little bit of engagement. So if you have to read something, my suggestions usually involve writing stuff down and trying to remember what you've done. So if you're learning something by reading, your two keys are jot important things down as you go, like an outline. If you have some kind of topic that's important, put it on a piece of paper, type it into something. I do both. I'm totally fine with that. And then in small chunks, if you're really trying to learn, you want to look at what you've read, write some things down, move away from it for a second, shut the book, get it out of the way, and say, what was it that I just read and what were the key points? And then try to write those down. Because then you're forcing your brain to get back to the material and do something with it. There's other cool things you can do with reading. You can turn stuff into an outline. You can turn stuff into a mind map. So you start with a central concept and you try to map the concepts around it. That's another good way to learn by reading. I know a lot of you are going to have to do more reading right now than you're used to. So that's one other way to do it. By the way, these are techniques you can also use when somebody's talking, and probably should. To be clear, your brain is not good at remembering any of this information. Your short-term memory can pick up like 3 or 4 things at a time and keep track of them. If you're constantly adding things, it's constantly removing them to add more. You're not going to get those in long-term memory right away. But if you have notes, then you have ways to trigger your memory later when you're trying to get it to figure out what's going on, which is the important stuff. So your action tasks should include a period of time and something to do. And that something should be active. You need to be writing or moving or typing or being involved. And that's the best way to do something. So what about when you're overwhelmed with all the different things that you've got? Well, don't worry. Happens to me too. I have so many things going on. You'd think sitting at home would be easier, but no, I'm just as busy. It's real funny. I just don't leave the house as much, except to go running. I still like to go running. So then you need to have action tasks that go along with everything, and then you need to prioritize them. Now, sometimes that's part of the difficulty, is figuring out what your action items are due when. So for each class, you're going to have different things due different times, and each one's going to take different amounts of time. The key would sort of be to figure out what to do, maybe not on a per day, but maybe a per every 2 day kind of basis. If things are due over the course of a week, then you got to figure out how long it's going to take you to do each thing, how to break that thing into action steps that you can map, and then how to combine it with the other things that you have to do. So let's say for one class, you have to watch a video and write a paper. For another class, you have to complete a cluster of math problems. And for a third class, you have to read something and take a test on it. That's a bunch of different things. You don't want to spend a long time on each or any of them. So you want to break each of them up. So the reading one, you clearly want to break into pieces and again, have something written down for each one. For the math problems one, you want to do the same thing. Is again, don't try to say I'm going to solve so many problems, but I'm going to work on these math problems for some number of minutes. And for the one where you have to listen and do something, same thing. If it's not a short listen, if it's short, like 10 or 15 minutes, then listen to it and then do something with it. And then you'll be okay. But then you have to write a paper, and that's going to take pieces as well. So I would probably break each of my days up into 2 or 3 segments, where each one I accomplished one small goal from each class. So if I had 2 hours in the morning, which is about what I have, for my 2 hours in the morning, I would maybe do 20 minutes of one, 20 minutes of another, 20 minutes of a third, take a break. Then, or 20 minutes of a fourth. If I have 2 hours, I would do it that way. I would get all of those things in. Or do the 20 minutes, take a break, and do 3 more 20 minutes, because that'll give you 2 60s with a little bit of a break in the middle. And the break should be something active and non-school related. So I have all kinds of fun things that I might use for breaks. I'll show you what I'm hiding underneath my table here. This is my fancy kettlebell. Fancy kettlebells are good because I can lift it up above my head. I can do squats with it. I can do something active. So that's one of my goals, is always do something active. I still have a little bit of a cough, but it's almost gone, I promise. So that's the best way to do that. Then maybe eat something, because if you have 2 hours in the morning, you might want to eat something after that 2 hours. And then maybe spend another 2 hours in the early afternoon, depending on how your morning works. I've been trying to do regular stuff in the early part of my morning. So I exercise, I walk the dogs, I do a little bit of house cleaning, then I do work, then I have lunch, then I do work. And that's a good way to keep my work sorted. And then when I come back in the afternoon, I'll do another 2-hour block in which I would have 20 minutes, 20 minutes, 20 minutes, 20 minutes, 20 minutes, 20 minutes, keep shifting, keep doing something. Now, depending on how your brain works, you might not want to move that quickly. You could do, instead of 3 20 minutes, you could do 2 30 minutes. Or if you can really stay focused, you could do one 50 minutes with a 10-minute break and then keep going, or 45 minutes or something like that. But different people work different ways. And it depends on how easy it is to move from one thing to another, but that will depend on your actions. If you have to completely rethink what you're doing, it's harder to move. But if your actions are very clear and it is pick this thing up and immediately do this goal, then it's a little bit easier to accomplish. I'm a real big fan of actions. Anything bigger than literally do this is hard to do. So paper writing, for instance. Paper writing is a really hard to do because it is a big process. How do you write a paper? I don't know how to write a paper. What am I doing? So usually we teach people to break it into pieces. And if you haven't still used those, you should. So for paper writing, you might first want to have a topic, a summary of what you're planning, or an outline, something on paper where you can just follow it. Then you need to figure out if you need to do any kind of research or gather any data. That's an action step. An action step is literally take the stuff you need and put it in a place. I used to gather up all my supplies and put them somewhere, or I would hunt down references and create a reference list with notes under the references, so that at that point, that's all I'd have to look at. When I have students do lab reports, I also typically tell them to start in weird places. That's a really good paper writing technique in general. Don't start at the beginning, start somewhere else. In science, the method is a great place to start because you don't have to think that hard about it. It's just what you did. You write down what you did. And you might not get it right the first time, but you at least write down what you did. Or I'll make a graph and I'll put that in a place. Then maybe I go back and I try to do something. Or I'll write a bunch of definitions. It's like, oh, I need to define all of these words. I'm going to define all of these words. It's not the beginning of my introduction, but it's somewhere in there. Or I'll write a hypothesis, which is the end of my introduction. Doing things out of order is good. It is hard to start something. It is easy to do pieces of something. So those are some of the things I definitely suggest. Make sure you have some accountability, somebody who's checking in on you, or you're checking in on somebody. Poke each other. Hey, did you do that thing you're supposed to do? Find friends online to poke. Poke me. I love to help people out. So say, check on me if I did that, and I'll put it in my calendar to check on you. Or make an actual check on yourself with the calendar thing that says, hey, did you do your job or did you not? I don't know. Can't tell until you do it. So not always easy to check out. All right. I said that I was going to also talk about science. So I'm going to go ahead and talk a little bit about science. Okay, so if I'm going to talk about science, I'm going to talk about some different kinds of blood cells, because that was one of the things my students are doing. Let's talk about the similarities and differences of some blood cells. So some of these are very easy. If you're comparing a white blood cell and a red blood cell, well, what's going to be similar about them? I always say pick the easy thing. In this particular case, they are both blood cells. They're found in the blood. They travel through the blood. They do things related to the blood. Then you want to figure out what's different about them by considering what each of them does. The job of the red blood cell is transport. And specifically, it carries oxygen, and it can also carry carbon dioxide, so that's important. Another neat thing about red blood cells, they contain hemoglobin, which is the protein that carries the oxygen. Also, they tend to be small, and they have no nucleus, which is a kind of funky little red blood cell thing. They don't need a nucleus because they do all kinds of other stuff. Put that on a second line and fit it into the box. All right, so what about white blood cells? What makes them special and unique? Well, their job is a little different. They are cleaners in a lot of ways, and they do cleanup. In some cases, they clean up invaders, such as bacteria and other things like that. They also can clean up dead things, which is important. They have a bunch of different kinds, so there's different kinds of white blood cells, and each of them has different jobs, which is important. And they also can digest materials. That's another one of their jobs. So that's white blood cells versus red blood cells. Okay, so next thing, I'm going to consider two things that belong to one of the previous categories, neutrophil and eosinophil. What is a neutrophil and what is an eosinophil? Clearly they're similar. They both end in "phil." And in fact, they're similar because they are both white blood cells. Which also means that one of the things that they do is they fight invaders. So that's a key part of their job. Fight invaders and be white blood cells. But clearly they're different from each other. How come? Well, there are many more neutrophils. That's one of the key things. Neutrophils are fairly general. They can go after lots of, but they do tend to go after bacteria. So they are bacteria. They're good at attacking. It's one of their key concepts. So there's many more of them. They're fairly general and good at attacking bacteria. Now, eosinophils are far different. There are less of these. That's really important. There's actually very, very few of them. Of the white blood cells, there's like 70% neutrophils and like 8% eosinophils. But that's because they're very specific to certain kinds of things, and they're particularly good at parasites. So they're specific to parasite invaders. If you have more eosinophils, you're more likely to have a parasite, and they're much better at killing parasites. Neutrophils can do that, but not. Eosinophils are less likely to kill bacteria. Neutrophils are more likely to. All right, so here's another comparison. An erythroblast and a monoblast. So what is it about erythroblasts and monoblasts? Well, something is already clear about them. They both have blast at the end of the word. Now, that's something that might be familiar to you if you've seen other cells that end in blast. For instance, fibroblasts are cells that produce fibers. So maybe blast cells produce something. So that would be a key similarity between them, that they produce something. But of course, we need to know what they produce. So erythro also has a very similar sound to it, because it sounds like an erythrocyte. What's an erythrocyte? A red blood cell. Mono, from monoblast, also sounds like something I've heard of before. A monocyte, which is a type of white blood cell. So maybe they produce cells. If each of them produces cells, then they are a cell that produces other cells. And a cell that produces other cells is called a stem cell. So they do each produce something, and they are stem cells because they produce cells. Erythroblast, we just said, is the same as erythrocyte. It is a stem cell that produces red blood cells. And that means that monoblast must produce, so monoblast produces white blood cells. So they're similar to each other, but also a little bit different. All right, and finally, we'll compare two different types of blood, type A blood and type AB blood. Obviously, these have a similarity because they both have the letter A in them. So what does that mean if you have a type of blood? Well, if you'll recall, type of blood typically means that you have something on that blood cell that names it that gives it that title. And something on a cell that tells what it is an antigen. So in this case, both of these would have A antigens on cells. So both of these sets of blood cells will have A antigens because they both have A. But type AB, see, now that one's a little bit different because it also has a B. It must have B antigens on cells, which the type A blood does not. On the other hand, what's that going to do if the type AB blood comes in? Well, if the type A blood does not have B antigens, that would mean it would want to attack a B antigen because it would be a foreign invader, and you don't want a foreign invader. What's the thing called that attacks? Well, it's not an antigen, but an antibody. So in this case, it would have like B antibodies to attack B antigens. And that's the difference between the two. So you could give somebody with type AB blood type A blood, but you cannot give somebody with type A blood type AB blood. They would destroy it because they would attack it. I should spell that correctly. And that's how you compare these different kinds of cells. All right, let's see what's going on elsewhere. Close down some of this stuff, move this thing to the bottom. Still not a lot going on here. People should come and hang out with me. If you come hang out and drop something in the chat, I will answer questions, sing songs, do stuff. You let me know. Otherwise, I'm just going to sit here and keep talking about random cardiovascular stuff. Ask questions here. See, it's a chat. You're supposed to chat. There's nobody in my chat so far, just me. Ooh, I can pop out the chat. That's real cute. And put timestamps on it. Someday, people are going to show up to this, and it's going to be fun. All right, but since no one is asking me questions, I guess I'm going to talk more about the cardiovascular system. So, cardiovascular system it is. All right. Now let's look at the heart in terms of some different case studies of some different people and how this might affect their cardiovascular system. So our first patient is a male, age 68, which is not young, who eats a high salt, sugar, and fat diet together. Now, I'm not entirely against those three things, but together can be problematic. All right, so the first thing is, how does age relate to cardiovascular health? Well, how does age relate to anything? There's actually some very specific things that happen as humans age, because a number of things in the body change, slow down, adjust, so you don't get quite as much replication in some cases. But the key thing that happens with age tends to be with connective tissue. Connective tissues tend to become less elastic with age. So connective tissues are made mostly out of proteins. They're not cells. They don't renew themselves very rapidly. That's an important concept. So therefore, it's just a protein essentially sitting there for most of your life and not being renewed very much. And in the cases of your connective tissues, they're a little bit like rubber bands. What happens if you leave a rubber band on a shelf? Well, if you leave it on a shelf for too long, it becomes hard, and if you try to stretch it, it snaps. Same thing can happen with your connective tissues if you don't use them, lubricate them, and take care of them. So as you age, connective tissues become less elastic. So then how does that relate to blood vessels? Well, this is important because blood vessels are built in kind of very specific ways. So they have an inner layer, if you'll recall, and that inner layer is epithelial tissue. So it's just a lining of cells that holds things together. Then, right outside of that, there is a different layer, and it is a muscle layer. Thump, there's muscle around it. That's probably a little bit too thick. Let's make the muscle layer a little bit skinnier. If it's veins, it's real skinny. If it's arteries, it's a little bit thicker. So that's the muscle. And then outside of the muscle, now you have the last layer that holds everything together, and that is the connective tissue. So if the muscle wants to expand, it's going to push on the connective tissue. If the connective tissue is elastic, then that vessel can grow, which, as we learned with blood pressure, can help improve the ability of blood to flow. So if the vessels dilate, vasodilation, then that can lower blood pressure. If that outside green connective tissue line is very stiff, then the vessels cannot dilate, which means that if there's more going through this middle section, it can increase blood pressure and put stress on these vessels, which is a problem. So that's how age relates. How about diet? Well, there's a couple things happening here. We're going to take them apart. We'll start with salt. What happens when you have salt in the bloodstream? Well, if I remember correctly, when you put salt in the bloodstream, I'm going to go ahead and make my salt blue. It's having lots of little salt particles. And what does the body want to do with salt particles? Does it like having a collection of salt? No, it wants to attempt to balance it. And the key with balancing water, so we want to balance salt and water. So what do we call that? Osmosis. So you might remember this concept. Balancing salt and water is osmosis. So if you have lots and lots of little salt particles, what's going to happen? Well, it means that when the water is trying to balance, it's going to come towards the salt particles and try to push them aside or spread them out. Okay, so based on that, that's going to add liquid to this vessel, which we just said is less elastic. So that's going to do to blood pressure. Oh, it's going to make it go up. So that was one of the things. So now let's consider the sugar and fat. Now, those two things on their own, possibly okay. If there's a lot of sugar, you'll get more osmosis. So that is, again, going to push more water into the bloodstream. But the real key with sugar and fat is that sometimes when they come together, they can cause problems on the insides of vessels by causing little plaques. Oh no, now there's a plaque in the blood vessel. What's that going to do to the space on the inside? It's going to decrease it. So even though you're not actually constricting the blood vessel, it acts like it is because now the water has less space to go through. And we just said there's more water. So what's that going to do? Again, increase blood pressure and put pressure in general on the entire system to get oxygen to where it needs to go, which is always the important part. Nobody loves me. I'm still going to do it. All right. So now, if this person comes to you with all of this information and says they have chest pain and tightness, what are you going to think? Well, I'm probably going to think that that means there is a problem with the heart. And a big problem with the heart is typically getting oxygen to the muscle so that it can press appropriately, because now it's being stressed to push a lot of liquid through a small space. And it only happens when you try to do something difficult, which would mean you would need more oxygen, and then it goes away. So it sounds like the coronary arteries are very possibly somewhat clogged up and not getting oxygen to the heart fast enough, and then it slows down. When that's only happening a little bit, sometimes we call it angina, meaning that the vessels are blocked up but not completely blocked up. But you do need to be careful, because if they block up completely, then this person could absolutely have a heart attack. So the goal is to go in and try to keep those vessels open using some kind of method. And we have lots of methods for that, but it's always hard to say. All right, let's keep considering some of the differences and the stuff we'll encounter here. Oh, this patient has even more things going on. The next thing that happens, you listen to his chest and hear an odd sound along with the standard lub-dub of the heartbeat. Well, to understand what's going on there, first of all, we need to know what we're hearing when we say the lub-dub of the heartbeat. So we've talked about the heart and how the heart's set up. And when the heart squeezes, it squeezes the top first and then the bottom. And so it has two parts to it. But you're not going to be able to hear muscle movement. Muscle movement doesn't really produce a sound. Even if you put a stethoscope up to somebody, you won't hear muscle movement. You won't hear electrical movement, which is what forms the EKG. So that's not very helpful. So what are you listening to? Well, if you think about how the heartbeat works, the blood comes into the top part, to the atria of the heart. It drops down into the bottom part. And then what happens? A valve closes between the top and the bottom on each side. So actually the tricuspid and the bicuspid valve on the right and left sides close at the same time. That's what you hear when you hear lub. Then when the ventricles squeeze and it pushes the blood out of the heart, boom. Now the semilunar valves, the one going out the pulmonary artery and the one going out the aorta, they shut, and that's a dub sound. So the sounds you hear are flaps of valves hitting each other. All right, so if something sounds strange, it may or may not tell you that the heart's actually beating in a certain way, but it might tell you that the valves are not hitting in the right way. So typically we would call this odd sound of the heartbeat a heart murmur, and it usually means that a valve isn't closing properly and blood is able to backflow through it. It's pretty common with the mitral valve. It happens with the lub sound, and the blood pops just up a little bit and usually falls back down. This can just be the way somebody's heart works for all of their life and they're fine, or it could be an issue. Only a doctor would know. All right, next up in our little case study, we're going to examine this EKG, which, as we've pointed out before, talks about the electrical signaling in the heart. So the way the electrical signaling is supposed to work is it's supposed to make a little peak when there is the atria and the electrical signal goes around. It's supposed to make a big peak for the ventricles, and then it's supposed to make another peak for it to relax. That's not what's happening here. This is not a normal EKG. We could take a look at a normal EKG just to get a sense of how different it is. So a normal EKG picture should show a very simplistic version of this, again, where there's a little bump and then a bigger one and then a more obvious one. And that's not what's happening here. It's very jagged in the middle. Now the big bump is still happening. That's important. That's the ventricles. So the ventricle part is fine. But the part where the atria are supposed to be either squeezing once or stopping is very jagged. When we see a jagged line like this, we call it a fibrillation. In this case, since it's the atria, we'd call it an atrial fibrillation, which is not great because it means the atria aren't pushing correctly. But where's the blood going? Well, it's dropping down in the heart. So most of the time it will get there. Ventricular fibrillation is much more problematic because you need the ventricles to push the blood out to the body. And typically that is when we call it VFib and need to fix it or somebody's going to die. So in general, what might we tell this person? Well, probably eat better and maybe do some things to keep the elasticity of your connective tissue, like be active. And then also be careful because it sounds like the heart's not working quite right. But at least we've figured out all of these issues. All right. Here's another case. This one is a female. She's a little bit younger, but she is pregnant and on bed rest. So how's bed rest going to affect the circulatory system? Well, we know how blood gets out to the body because it gets out to the body when the heart pumps it out. Most of the time, that's not a problem. Your body pumps blood out to your extremities even when you are laying down and asleep. But how does it get back? Once it gets all the way out to the capillaries, it loses a lot of pressure, and then it needs to find a way to get back to the heart. Interestingly enough, your heart does not pump blood back to it. Something else does. So think about it. If you are not moving for a long time, especially your legs, you think about it as not really circulating your blood. The key to that is because the muscles in your legs are actually the main way the blood gets back to your heart. And it is in fact called the skeletal muscle pump because the skeletal muscles in your body pump the blood through the veins and back up to the heart. So let's think about that for a moment. If we have a vein, so I'm going to go ahead and draw a vein, for example, in a leg, and around it, we have some muscle. So I'm going to draw some muscles around this vein. As they squeeze, they'll go ahead and push on the vein, which will then allow the blood, which I'll make blue, even though we know it's not actually blue, move up in the vein. But your muscles aren't pumping all the time, right? So what happens when you stop moving? Does the blood just fall back down? No. You see what happens is it is able to hit these little valves. So they're like the valves in your heart, except that they don't move on their own, but they do bump up to allow blood to come through and then fall back down again to catch the blood. So the blood will come up through the valve, and then when it tries to fall down again, it can't. And it gets stuck moving upward and upward and upward. So that is your skeletal muscle pump. So if you are laying down or sitting constantly or on bed rest, your skeletal muscle pump is not going to work as effectively, which means the blood might sit in the veins. And if it does that and it doesn't move, some of those sticky parts like the platelets might form a clot. All right, so if then the next thing that happens is the patient tells you they have a sharp pain in their lower leg, that is probably indicative of a clot, because a clot is going to stop some of the blood. It's going to cause a bit of a pressure backup, and that is going to cause pain because it's going to push on the blood vessel walls and the muscles. Now, a clot in your leg is bad. It hurts. It can cause problems, but it's not the worst thing. And usually you can fix it with a little bit of compression and some other stuff. But what happens if that clot detaches and moves? So let's follow the pathway of this woman's problem. And if we do have a clot in a vein and it gets unlodged, it might find its way back up to the heart, which is not too big of a deal because the heart valves are fairly large and the heart vessels are fairly large. And then that blood with no oxygen is going to go from the heart to the lungs. And if that clot gets stuck there, call it a pulmonary embolism. And it can actually stop blood flow in the lungs, which can then cause a major problem. So it's one of the reasons we don't like blood clots, because they don't always stay in the legs and then they can cause lung problems later. The cardiovascular system and the pulmonary system are actually very tightly linked. All right. Final patient is a runner with high blood pressure. And we already talked about blood pressure in another video and talked about how it is controlled. So you know about how exercise would affect it. So the last thing that we want to answer today is to think about congestive heart failure. So what is congestive heart failure? Well, congestion is something you might be familiar with, only usually you think about it as stuffiness in your head. But it's kind of the same thing with heart failure, because secret trick, what causes the stuffiness in your head is inflammation or swelling of vessels and fluid collection. In congestive heart failure, you have swelling of vessels and fluid collection throughout the body. So if everything is swollen and pushing against the vessels and full of fluid, what's that do? Well, it increases blood pressure and it also puts stress on the heart. If the heart is stressed out too much, the muscle of the heart can get tired. It can enlarge and it becomes less efficient, and that can be a problem. Fortunately, one of the best ways to improve that is indeed actually using blood pressure or using exercise to improve it and make your heart better. So exercise, it's a good idea. All right, where are we now? Is 11:45. Still nobody hanging out except for me. So maybe I'll be done. I don't know if any of my students will show up tomorrow and ask for singing. This has been fun. See you all sometime in the future.